So I've made several videos with this robotic arm, but I've yet to do anything useful with it, and I want to change that today. So I have a very dusty section of baseboard heating, and I want to see if I can do some dusting with this robotic arm. If you look at the tip of the robotic arm, I have put a cotton ball over the tip of the pencil. I guess it's the eraser portion I put the cotton ball over. And then I used a crimp that probably was holding some sort of plastic bag of food closed, and I used that to hold the cotton ball in place. So now I'm going to try to program this arm to do some dusting. Here's a side view of the robotic arm, some measurements that I took. I have some coordinates from those measurements. I have to say that I apologize in this video. I'm not completely consistent in the coordinates that I use. So I'm calling the point right at the bottom, the base of the robotic arm, the origin, and I'm setting that at 0, 0. And then going up point S1 is where I guess the second servo up, so the middle servo, where that rotates from. So that's 0 in the X, it's 96 millimeters up. Point S2 is where the highest servo pivots from. So that's negative 14 in the X direction, 160 in the Y. And then the tip up here where I have the cotton ball I'm calling S3, that's 17 in the X, 306 in the Y. And then the baseboard is, the front of it is 162 in the X and 93 in the Y, so 93 high. And then the back of the baseboard, it's 206 in the X, and it's a little bit higher than the front. It's 103 in the Y. So what I'm going to do first is just stay in this one plane. I'm not going to pivot the arm horizontally. And I'm going to rotate the servo at point S1 and S2 in order to try to get to this point. I'm going to input those measurements into the spreadsheet that I created, and it's going to output the angle that I need to program both the servos to in order to get the tip, so the cotton ball, to the intended target. I did create another a previous video on how to get the tip of a robotic arm to an aim point, which goes into all the details. If you're interested, you can look at that. But for this video, I'm just going to use the spreadsheet to get these numbers. So it's still 0.96. Today I measured this point S2, negative 14 and 160. S3, I created that new, called the end effector. So I measured that at the tip, it's 17 for the X and 306 for the Y. And then the height of, I guess, the most outboard, so the closest to the robot portion of the baseboard heating, I measured to be 93 millimeters. Above the surface that the robotic arm is on. And then it's about 162 millimeters from the base of the robot is where the baseboard heating starts. So my spreadsheet, this calculation is telling me that servo 2 should be positioned to about 54 degrees, and it's saying that servo 3 should be positioned to 157 degrees. So my plan is to walk the robotic arm closer and closer to the baseboard heating, because I don't want it to crash into the baseboard heating or the wall and damage anything. So it's a very conservative approach with these iterations. So here's my code for the first step. So I've included the servo H library, calling out my 3 servos, 1, 2, and 3. For the integer servo position, initially setting it to 90. That's the neutral set point for all these servos. And then these are the pins for each of the servos. Pin 9 for servo 1, pin 6 for servo 2, pin 5 for servo 3, and the servos, the numbers as they go up the robotic arm. So 1 is at the base, this turns it horizontally. 2 rotates vertically, but it's the first one up, and then 3 is the highest servo on the arm. And I'm eventually writing the variable servo position to each of the 3 servos, 1, 2, 3. I have a 1 second delay, and then my loop is going to have the servo position variable go from 90 down to 72. It's going to go down 1 degree at a time. I'm writing this variable to servo 2. I have a 10 millisecond delay between each angle. I'll control the speed that it moves at. Once servo 2 goes to that position, there will be a 1 second delay. And just to reiterate this, so the spreadsheet said that I need to bring servo 2 down to 54 degrees, but I don't really want to get anywhere near the wall this time, so I'm just going to go about half the distance, so 72 degrees. And then for servo 3, I have this loop. I'm going to have the variable servo 2, servo position, start at 90, go up to 120 degrees. Again, 1 degree at a time. I'm writing that to servo 3. There's a 10 millisecond delay between every 1 degree move. And then I have a 5 second delay when the arm is down. And then this is these 2 for statements undo what I did and bring the arm back to the neutral position. So we'll bring servo 3 from 120 degrees back to 90, and I'll have servo 2 go from 72 degrees back to 90, and then there's a 5 second delay before it repeats. So I'll go ahead and press this arrow button to upload the code to the robotic arm. Okay, so here's the first iteration. So I've modified it so that servo 2 is going to go all the way down to 54 degrees. I guess the position it needs to go to for the tip to hit the mark. And then servo 3 is going to go to 147 degrees, which is 10 degrees short, and then they'll return to the neutral position. During that last iteration, it looked like the cotton ball was headed in the right direction. So this time I'm going to command the arm to go down to the intended position, hoping that the cotton ball does go ahead and make contact with the baseboard heating. So we'll see how this goes. Looks like it's sitting. Let's get a closer look. Right there on the surface. So now I'm ready to try to do some cleaning. So my plan for that is when the robotic arm is down to have servo 1, so the horizontal servo, sweep. Let's go 10 degrees. So we'll go from the neutral position 90, 10 degrees. So I think this will be, actually I don't really know if it's going to be 100, I don't know if it's going to be clockwise or counterclockwise, it really doesn't matter. And then this will be writing to servo 1. I don't really need much of a delay after that. So I'll do a 1 second delay, and then eventually we need servo 1 to go back to its initial position. So at the end, let's have it go from 100 back to 90, servo 1. So we'll save this and then upload it and see what happens. Yeah, there's the swipe. And just continuing through the loop, doing it again. And it's hard to tell, but it actually is a bit cleaner right there. So that was successful, so I'm going to have to add more points to it so I can clean more area. Now I'm going to continue to swipe at different points, just like I swept that 1 point. So I have 6 different points that I've identified on the baseboard. And right now we're looking at overhead shot of the robotic arm. You can see the white cotton ball and then the baseboard at the top of the screen, and marked each of the intended aim points with X's. So first, I'm going to try to hit the upper rightmost X, and just like I did before, swipe to the left. I'm going to come up a certain distance, have the cotton ball clear the baseboard, and then go back to the right and hit the middle X on the right, sweep back, continue to the lower right, and then this upper left X, the middle left X, and the lower left X, and hit the 6 points and sweep and get a little bit of the baseboard clean. This is a more detailed look at the 6 points that I showed before. And this slide I'm showing the measured coordinates of these points. And as I mentioned before, I'm not consistent with the coordinate system I use, so I'll go over that now. The X values are the distance toward the wall or away from the wall. So 162 is the value for the point on the baseboard that's furthest away from the wall. So that means it's 162 millimeters in this direction from the origin to that point. The middle of the baseboard is 177 millimeters, and the point of the baseboard closer to the wall is 192 millimeters. For the Y values, this is the distance moving parallel to the wall and the baseboard. So these points on the left, they're 20 millimeters offset from the origin where the robotic arm is. The further to the right points are 40 millimeters offset. And then the Z values are the height. So the points that are on the baseboard further from the wall are a little bit lower. They're 93 millimeters, in the middle it's 98 millimeters, and closest to the wall, they're 103 millimeters. My next challenge is that for each of these points, I need to determine what angle for the 3 servos is going to get the tip of that cotton ball to each point. So I'm going to go ahead and show you how I figured out the angles to get to the upper rightmost point. And I did that using my spreadsheet that automates the algebra and the geometry. To find the values I need, I set the surface height at 103. That's the Z value. The Y value, this offset, I set at 40. And then for the X, which is 192, that's what these rows are down here. So I need to scroll down to 192, and then I go to the right, and this is telling me that servo 1, so the horizontal servo at the bottom, needs to rotate 78 degrees. So it will train to the right 12 degrees from 90 to 78. And then what it's also telling me is that the distance that the arm is going to have to travel or stretch to get from the origin to the point of the baseboard is 196 millimeters. So what I do now is I go down to 196 millimeters, and this is telling me that servo 2 to extend this distance needs to be at 27 degrees, and servo 3 needs to be at 118 degrees. Pictorially, what the spreadsheet just showed was that for servo 1, so the horizontal servo, that it needs to train, so it needs to rotate to 78 degrees. This angle right here is going to be 78. Now this diagram isn't really to scale, so 90 is where its neutral position is. It's going to rotate 12 degrees down to 78. Then the other 2 servos, what they control is how far the arm stretches. So we found that it's 196 millimeters from the origin to this point right here. So the servo 2 will be rotated 27 millimeters, and servo 3 will be 118 millimeters to extend that distance. I repeated those steps on the spreadsheet for all 6 of these points, and in the blue font I show for each of the points what the servo angles need to be. Now I'm going to go to the code to show where this information is in. Right here I set servo 1. So it's servo 1, and I'm setting it to 78 degrees. So it's going to train 90 degrees, rotate to the right to 78 degrees. So now the robotic arm is lined up with that uppermost right point. Then servo 2 is going to rotate from 90 to 27 degrees, and servo 3 is going to rotate from 90 to 118 degrees. So at this point, that cotton ball is touching the baseboard, we're hoping, at the intended point. So we can have servo 1 sweep 10 degrees, so from 78 to 88 degrees. And then after that cleaning stroke has been done, the next two servos, servo 3 and servo 2, are then pulled away from the baseboard a certain distance, so we can now go to the next point and continue to clean. So these lines of code right here are for that upper rightmost point, and then I just continue the rest of this code with something like this for all 6 of the different points. So now the code has been written. I have to say it's pretty cumbersome code and a lot of room for to make mistakes, but yeah, it's pretty straightforward and it should work. So I'm going to go ahead and I'll click on this arrow and upload the code and see what happens. The coding was cumbersome, only a small area was covered, it's somewhat incomplete, but the robotic arm did some cleaning for me. It did something that was a little bit useful. I do want to mention that the reason I work on robotics is I'm trying to automate the gutter cleaning process in order to decrease ladder fall deaths and injuries. And I could use your help. On the next slide I'm going to show a list of items that would be helpful for me. If you could take a look at that, and if you have some extra items, I'd appreciate it if you'd give me a call and let me know. Thanks for watching the video.